Hello, today we are discussing how you determine the amount of protons, neutrons and electrons in an atom and an ion. Also, we will then go on to explain the electronic configurations of oxygen, sodium and arsenic. Firstly, what is an atom? An atom is the smallest particle of a chemical element that can exist. Each atom contains three subatomic particles, protons, neutrons, and the electrons, which are found orbiting the shells around it. To work out how many of these subparticles an atom has, we need the use of a periodic table. Elements have a mass number shown at the top, which indicates the number of neutrons plus protons. This is always the biggest number. And the bottom number is the atomic number, which shows the number of protons. This is always the smallest number. In an atom, the atomic number also shows the amount of electrons. However, this differs when looking at ions, which we'll explain later. For example, magnesium has a mass number of 24 and an atomic number of 12. The number of protons and electrons is fairly easy, as the atomic number is also known as the proton number. Therefore, magnesium has 12 protons and also 12 electrons. Next, to work out the number of neutrons, we look at the mass number. Now we know the number of protons, we can take away this number from the mass number, thus leaving the amount of neutrons left. So, 24 minus 12 equals 12. Let's look at a slightly harder example, platinum. Platinum has a mass number of 195 and an atomic number of 78. Looking at the protons and electrons again, there are 78 of both. Now, to find the neutrons, we take away the amount of protons from the mass number. 195 minus 78 equals 117. Next, let's take a look at how to determine the number of electrons in an ion. An ion is a charged particle, which is formed by an imbalance of protons and electrons. So if there are more electrons, the ion's charge will be negative, whereas if there are more protons, the charge will be positive. An ion is indicated by a plus or a minus next to the element. To work out the protons and neutrons is the same process as before, but to work out the electrons, we need to look at the charge. This element has a positive charge, which means that 2 electrons have been lost. Therefore, we take away 2 from the atomic number. 12 minus plus 2 equals 10. This means it has 10 electrons. If the charge was negative, we would add 2 electrons due to the fact that electrons have a negative charge and 2 negatives make a positive. Now we are going to discuss the electronic configurations of oxygen, sodium and arsenic. The Bohr's model only takes you so far, and we want to explore further into an element subshell. A subshell is a subdivision of an electron shell. The first subshell is called the S shell, which can only hold up to 2 electrons. Next is the P shell, which can hold up to 6 electrons. And then the D shell, which can hold up to 10 electrons. To illustrate how electronic configurations are written, an example we could use is carbon. We know carbon has 6 electrons, which like to fill up their subshells in order. So it would be 1s2, 2s2, 2p2. To make this easier, the periodic table is divided into these shells. Over here, the first 2 groups fall under the S subshell. Then groups 3 to 0 are part of the P subshell. The rest in the middle are in the D subshell. Each row is also divided into numbers. So 1, 2, 3, 4, and so on. A good example would be oxygen. Looking at the periodic table, we can work out the ending of the electronic configuration. The location of oxygen is in the P subshell section, and we know it's on the second row. We then count in 4. and know the ending is 2p4. From there, we can work backwards to fill up the rest of the subshells. We know the order that electrons fill up shells, so oxygen will start with 1s2, then 2s2, then end with 2p4, which we worked out earlier. Another example is sodium. From the periodic table, we can tell that it ends in the S subshell, and it also falls on the third row and the first column, meaning its ending will be 3s1. The other 10 electrons will fill up the other subshells. Remember, S can hold up to 2 electrons and P shells can hold up to 6. So the final electronic configuration of sodium will then be 1s2, 2s2, 2p6, ending with 3s1. The last slightly harder example is arsenic. It's in the P section on the 4th row, meaning it will end in 4p3. The overall electronic configuration of arsenic would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, followed now by the D section, which can hold up to 10 electrons, so 3d10, and then ending in 4p3. There is a way to write the configuration as an abbreviation to make writing it faster and easier. Using arsenic again, now we can use the closest noble gas to the element. Looking a row above, argon is the closest, which means we don't have to write 1s2, 2s2, and so on. We can just use Ar, which represents the same beginning as arsenic. Then we continue by writing the following subshells until we reach arsenic. The final abbreviated configuration would then be Ar, 4s2, 3d10, 4p3, which is much simpler. To summarise, atoms have protons and neutrons in the nucleus and electrons orbiting in subshells. The periodic table is the best tool to finding out the number of protons and neutrons and electrons using the mass and atomic number, as well as working out their electronic configuration.